This is Knowledge Engineering with Semantic Web Technology. This is lecture 3, Ontologies and Logic. In this part of the lecture, we want to talk about different ontology types and ontology categories. So, for example, you are able to divide ontologies among categories according to their level of generality. And there is a model from Nicola Guarino, and he distinguished so-called top-level ontologies, which are the most general and cross-domain ontologies, from domain and task ontologies, which are then on a mid-level, from so-called application ontologies, which are the most specific ones. So we will have a closer look into this model. So first of all, top-level ontologies, also referred to as upper ontology or foundation ontologies. So they are usually general, cross-domain ontologies, and they represent also rather general concepts. So the example you see here is the so-called middle-aged tree of knowledge, which is based on the categorical system of Aristotle. So he tried to distinguish several most general categories within the world in which everything in the world could be classified. And this also is the purpose for these top-level ontologies. So usually they represent very general concepts, for example, time, space, events, and usually they are rather independent from a specific domain or problem. So if you want to look at a contemporary upper ontology or top-level ontology, you can look at these KR ontology from John F. Sowa. So this is a top-level ontology. And this is rather interesting because here the concepts, so the classes in the ontology, they are organized within a so-called lattice. That's an algebraic structure, and everything here is ordered and connected that you see among a top and a bottom element, which represents either nothing or everything. So what you have here, you have 27 concepts, and these concepts are somehow in the first row in the upper level described by their property, like for example whether they are independent, physical, relative, abstract, mediating or something like that. So these categories, these 27 concepts, they stem from or they are based on a process philosophy from Alfred North Whitehead and from Charles Sanders Peirce semiotics. So you do not necessarily understand it if you look at it now. So if you want to have a closer look on that, of course, it's full of philosophical concepts, then you have to follow the link you see here, but there's a description of this so-called top-level ontology. And it's a rather small ontology because only 27 concepts or classes. Okay, so these are top-level ontologies. On the next level, we have the so-called domain ontologies, and they, of course, are focusing a specific domain. So they define fundamental concepts according to a generic domain. So usually within a domain ontology, the terms that have been defined in the upper ontology, in the top-level ontology, will further be specified. Like you see here, for example, in that funny picture, the types of ice cream are categorized, and this could be something like a domain ontology describing sorts of ice cream. Then on the other hand, if you do not describe an entire domain, you can also describe generic or general activities or tasks, and this is the task ontology. Here you describe fundamental concepts according to this general activity or task, like the life cycle that you see here on the left side of the screen as an example. So usually also here, the concepts defined in the upper ontology, in the top-level ontology, will be further divided and specified and specialized. And then you have the so-called application ontology, where both domain ontology and task usually are fit together. So these are rather specialized ontologies. They are focused on a specific task and a specific domain, and often they are specializations of both task and domain ontology. It means they specify roles that are played by domain entities for certain activities. And an example for that would be a specialized cooking book, like for example the famous book Mastering the Art of French Cooking by Julia Child, that you probably know. Okay, so these are different types of ontologies according to the level of generality. But of course, not only on that kind of categorization, you could define specific types. You could also use another property to form another categorization scheme for ontologies. So you could, for example, try to categorize the ontologies according to their level of semantic expressivity, whether they can only express very little, they are informal, or they are rather formal and can express very much. So here is another model or another categorization system that comes from Ora Lassila and Deborah McGuinness. And they have tried to order several forms or types of ontologies according to their semantic expressivity. And all starts with a simple controlled vocabulary. This is nothing else but a list of terms. And it ends, on the other hand, on really, really complex logics that, for example, contain value restrictions, general logic constraints, disjunctiveness, inversiveness, and other things like that. So this is, of course, another kind of categorization. So for example, in that categorization schema, you could put terms on the left end, followed by data dictionaries and folksonomies, and then comes the term of all kinds of formal taxonomies, and then logic programming, description logic, and in the end, then first order logic for the most expressive form of ontologies we want to consider here. So you speak also about so-called lightweight ontologies if your representation is somehow described in the left part here of that scheme. And you talk about heavyweight ontologies if they are at the opposite direction on the right side of the slide here. Okay, let's have a deeper look into that model. So we start with the first three. So we have controlled vocabulary. So a controlled vocabulary is pretty simple. You simply have a list of terms that you can use, for example, to describe things like in a catalog. But on the other hand, you do not formally define what these terms really mean. You only give a number of terms, and somebody, of course, who has the intelligence to do that is able to annotate things according to that controlled vocabulary. Then in the next level, you would describe your terms, but you describe them not in a formal way. You simply describe them in an informal way with the help of natural language, like in a data dictionary. And this then forms a finite list of terms, including an informal definition given in natural language. And that's a glossary. And one step further, if you also describe relations within a controlled vocabulary, then you end up in a so-called thesaurus. So this stems from the Greek and means treasure or treasure house. And there, these terms are, for example, described according to equivalences. So a thesaurus or thesaurus tells you which terms are synonyms, so which have an equivalent meaning. Then hierarchies can be specified. So what are subclasses? What are superclasses among your terms? Then also homonyms. So you can define terms and they can have different meanings. So this is also referred to as polysemic terms. So they are called homographs, written in the same way, but having several meanings. And on the other hand, of course, you can also describe associations. So what is similar, or what comes to mind, what is nearby. So these kind of relations among terms, among your controlled vocabulary, is given within thesaurus. This is a simple example. So for example, if you consider ice cream, the broader concept, so the superclass of ice cream would be a dessert, and narrower concepts would then be specializations of ice cream, like chocolate ice cream, strawberry ice cream, banana split, tutti frutti, or what else. And of course, there are so-called sister concepts, so what is on the same level. If you look at it from a taxonomic scheme, there could be also something similar, which is frozen yogurt, and an association with ice cream, of course, could be summertime. So these are relations among controlled vocabulary terms given within a thesaurus. An example for a thesaurus on the web would be WordNet. So you can access WordNet, the link is given here, and this is a link-based electronic dictionary with semantic relations, and it's organized in so-called synsets. So these synsets usually have a unique meaning, and usually one synset then gives you information about what are the hyponyms, what are the hypernyms, and stuff like that. So just take a look at it and try it out. You will see it's rather interesting to play around with a thesaurus like this one. Okay, let's go one step further. More formal way of describing things are so-called taxonomies. In general, taxonomy is the definition of a hierarchical system of groups. So the name itself comes from the Greek, and taxis means order or arrangement, and nomos means law or science. So it's a classification scheme or a nomenclature. So in science, most times it's a classification into so-called monohierarchical sets, so in classes and subclasses, like the one in biology that you know. And in biology itself, it's, of course, taxonomy is a subject itself in biology, and it means there it's the arrangement of all kind of organisms into a classification scheme according to similarities among these animals or organisms. And here on the right side, for example, of the slide, you see here the biological taxonomy, so the realm of life and its subclasses. Okay, but taxonomies itself can also be further divided. So we have here 3 different groups according to their semantic expressivity. It starts with so-called informal is a hierarchy. So there are subclass relationships and they are not really strict, which means that a subclass can be a subclass of several superclasses, like in a library index. A book, for example, can be organized or categorized among different categories. It can be likewise a thriller, like as well as it can be also a science fiction novel. So it means here the relation, the subclass relation, is not strict. Then more strict is a so-called formal is a hierarchy. So there you have an explicit hierarchy of classes and all subclass relations are strict. And then if you also consider not only the subclass relationship, but also an instance of relationship, so is member of or is instance of, then you end up in so-called formal instance, and you have even more semantic expressivity. So these are the 3 different variants of so-called taxonomies. So they are already rather expressive. But if you now think you can sail safely among the ocean of ontologies, beware of the dragons. Why is that? You might remember our first definition of ontologies. A shared conceptualization, which is explicit and which is also formal. But the point is, it is shared. So most times, if you for yourself define an ontology, you also put your viewpoint of the world into that ontology. Without sharing that, you might end up in rather strange things, so, which make sense to you, but not necessarily to everybody else. So this is one of the main points of criticism of ontologies like we do it right now. So, for example, here this famous author and librarian Jorge Luis Borges, he has written a very interesting book or essay, The Analytical Language of John Wilkins, and in there he defined also, or he referred to an ontology as an example, so he defined a taxonomy, and the taxonomy should describe also, like in biology, categories of animals. And he said in his essay, so this is a fictive or a fictitious category system of animals from a certain, in quotes, a certain Chinese encyclopedia. And here, the author of this Chinese encyclopedia divided the realm of animals into the following. He said, okay, animals are those that belong to the emperor, embalmed ones, those who are trained, suckling pigs, mermaids or sirens, fabulous ones, stray dogs, those that are included in this classification, of course, those that tremble as if they were mad, innumerable ones, those drawn with a very fine camel hair brush, and so on and so on, those that have just broken the flower vase, those that at a distance resemble flies. Of course, this is kind of a categorization system. The point is, does it really make sense to you? So it only makes sense if several people really agree about that. Only then you can communicate knowledge. So this is the main point in ontologies that are described in that way. So beware of ontologies. They not necessarily represent the absolute truth. But of course, they represent the truth according to the person who created the ontology, or according to the group of persons who share that ontology. Okay, so far so good. In the next part of the lecture, we will go a little bit more formal, and we will talk about the foundations of logic to be the first building block of our formal ontologies.